So, talking about normalization and scaling leads us productively to another discussion about data snooping. Let's say we want to make money. In particular, let's say we want to predict how the US dollar changes versus the Great British Pound, right? So we're going to be doing this problem that you see on the bottom where we have some time series data of, let's say, the last 20 days of how the USD and GBP differs from each other. And what we're going to normalize it. And then after we've done the normalization, split the data into a training set as well as a test set, right? To train the model on just the training portion and test just on the test portion after we've trained our model. We're going to take the training data, create some type of model, right? And then apply it to some test data. We're going to have a clear separation or split between these things before we train any model. You know, we do it this way. This is the normal way that we're supposed to do things, and we get very good performance. Great. So we're checking everything. There's no problem here. Training is correctly separated. So what we're going to do is we're going to go invest money, right? Because we got great performance. We're going to make a ton of money off of this. We're going to sell it to the bank. Uh-oh, we lost the money. Why did it happen? Well, let's take a look at the steps. Well, first we take the data, we normalize it because we know that certain algorithms are sensitive to data normalization. Then we do the split. This is, again, very standard into training and test. We train only on the training portion of the data, and we test it only on the testing portion of the data. This all sounds pretty legitimate. So what happened? Why did we lose money? Did you spot what happened? Key is here, right? We did the normalization, but what did we normalize on? We normalized on the entire data set, X, right? And when we split the data into training and testing, in fact, we got some information out of the testing data into the training phase, because when we normalize the data against the entire data set, you know, we are taking into account the maximum, the minimum, standard deviation of the entire data set. So there's some data snooping going on, right? If we had actually done this in the reverse order and split first, and then normalize the data, we wouldn't have this problem, because our normalization would just apply to X training data, normalize the data separately for the test set. We saw that this was a really important thing when you looked at what we did in week 2 notebook, that we actually had to normalize the data separately on the training set and apply the same normalization to the test set that was only done on the training data set. So to conclude about this part, we'd have to say that if a data set has affected any step in the learning process, here normalization and scaling, its ability to assess the outcome has been compromised. This is why earlier we saw that we're going to test on a validation set instead of the actual test set when we're trying to pick parameters for our model. And this is actually very subtle. Many people, even data scientists with a lot of years of practice, will fall into this trap, okay? There's many, many different ways to peek at the training data, even when you're being fairly careful. So take note of that and commit it to heart.